Hey my dear fellow monkeys, this video is part of the book review series. In this video I'll be reviewing the book A Mind for Numbers, How to Excel at Math and Science by Dr. Barbara Oakley. This book is a combination of scientifically proven methods of learning new things, especially math and science, combined with self-development. Usually I synthesize information from the book and go through the parts that I feel are important. But the book has made my job easier by giving a total of 20 major takeaways, 10 good learning habits and 10 bad learning habits. And I'll also be introducing certain things from what I have taken from the book in the list of 20 takeaways from the book. Before I go into the takeaways, there are also some mental tricks and mental gymnastics that we can do with our mind to help improve certain things like our memory using memory palace technique, or framing a particular thing. Let's say that you're going to start learning a new concept. The product, which is to learn and understand that. If you're just having the product, which is mastery of that particular topic that you're looking to understand, will be hard. So reframing that in a way that you get reward for the process. So every time you learn about that topic and move your understanding towards mastery, you give yourself rewards. It can be rewards in any form that you like. Concentrating on the process rather than product is another type of mental gymnastics that you can do to trick your brain to not feel terrible about starting something new. Having said that, I'll go into the takeaways. The first one is using recall. What I'll do is instead of going through point by point, I'll do a contrast between the good learning habits and bad learning habits whenever it can be done. So using recall to recall information using your memory from what you read the previous day or in the previous few days about a particular topic. Using recall to understand different topics is better than just passive rereading of the concepts. Another trick that the author prescribes is to try and recall the information in a different room compared to where you actually read that information, because the situation also plays a role in how you are able to learn a particular phenomenon. The other thing is that is continuously being driven home is the use of flashcards to first practice the things that are like fundamental principles in that particular topic, so that you have a basic understanding of that particular topic, so that you can apply it to different scenarios in which that particular theorem or formula can be used. The next one is chunking instead of choking. Clarify, chunking is basically, let's say that you're learning a new topic and there are 4 different subtopics in a particular topic. So what you do is you chunk the major topic into 4 of these subtopics, and what happens is you start making neural developments or neural connections between the 4 topics. Writing and speaking about that also improves the neural connections between these topics. So once that chunking is done and neural connections have been developed between these chunks, it can be stored as a separate chunk. And other topics in that particular topic or the major topic can be read, and those can be neurally connected to each other, so that you start accumulating more information about a particular topic, which is the path towards mastery of a particular topic. Instead of choking, as in before exams, students tend to cram all the information that they can so that they can vomit it out during the examination. It is not actual learning, you're just getting the grades instead of learning about a particular topic. Next one is spacing your repetitions. So when you're learning about a topic, as I said, repetition is a major part when you're newly trying to learn a particular topic. So learning over a period of time rather than just reading at the end is a better strategy to actually learn about things. When you're doing these spaced repetitions, what you'll be doing is you'll be recalling previous information and then applying it or using it in conjunction with the new information that you're reading at the moment. And it should be done over a period of time rather than doing it at once. The next one is alternating the type of problems that you solve. So once you get a hang of a particular phenomenon and you solve problems using that theorem or formula or that phenomenon, jump to problems that make you think about the problem using that formula in a different way, so that you are able to understand the different applications of each of these formulae or theorems or phenomena to different scenarios. This is also called interleaving, as in you're not just doing things continuously, not solving problems which have a similar solution pattern. Instead, it should be different types of problems using different formulae or application of a particular formula in different ways, which what will make you understand a particular topic. The next one is taking breaks. This is being derived from Dr. Daniel Kahneman, who wrote a book called Thinking Fast and Slow, wherein there are two types of thinking mechanisms in our brain: thinking fast and thinking slow. Thinking fast is usually intuitive, wherein you don't necessarily think about things when you're doing them. And the second thing is thinking slowly, wherein you're deliberating about a particular phenomenon. When you're trying to constantly solve problems of a particular kind, or you're stuck with a problem after having solved a lot of problems of a particular topic, letting your mind wander to something else helps your diffuse memory or diffuse thinking ability to take over and bring solutions. We have all had that moment. We'll be trying to understand a problem and coming up with a solution, but we'll not be able to. But all of a sudden, when you wake up the next day, you'll have the solution. Taking breaks helps us switch to the diffuse mode of thinking and helps us come up with solutions for difficult problems. The next one is using explanatory questioning and simple analogies. So this is mostly a memory technique, so that it will help you understand a particular topic. Usually we learn about things by analogies, and making ridiculous analogies in certain cases is also fine to make you understand, or to first make you have a memory of particular phenomenon when you're actually learning new. It does not necessarily have to be just analogies. It can be some mnemonic, it can be some sort of jingle, it can be some sort of rhyming poem or something like that, which will help you retain that information for a longer time, or it helps you make a link between multiple chunks of information. The next one is to improve focus. She calls this technique Pomodoro technique, wherein you set a timer for 25 minutes and you work for those 25 minutes without any distraction. You switch off your phone, you switch off your internet connection in your laptop, or if you have to work through internet, close all other tabs and use certain apps to eliminate distractions. This is called Pomodoro technique to increase your focus. The next one, she calls it eat your frogs first. It is basically doing the hardest thing first thing in the morning or whenever you're starting work. That is, when you're fresh, you start with the hardest job and go to less harder jobs later in the day. The last one is a powerful technique called mental contrast. This is especially useful when you're lacking motivation. Thinking about where you want to be and comparing it to where you are right now helps you give that motivation to push through and try to achieve that goal. She also claims that having a picture of where you actually want to be helps you motivate to learn more to be in that situation. The author claims that until and unless you're able to recall the key information from a particular page, you should not be highlighting the page. And highlighting information on the page is a bad way of learning, because it gives you an illusion of competence. Just because you have highlighted that doesn't mean that you have actually understood that topic. At the moment you might have been able to understand, but does it actually help you recall that information a few days later? That is true learning. Illusion of competence also happens in this scenario, wherein you look at a solution for the problem and understand or think that you are able to solve the problem when you actually do it. You are just thinking that you'll be able to do it, but when you are asked to do it, you might not be able to do it. The next one is, if you are a person who likes to study in groups, not letting that group session to become into a chat session. That is very important, and there should be some clear agenda for the group that is coming out for learning. It doesn't mean that there should be no fun time during that group meeting, but it shouldn't turn into a completely fun time rather than a learning time. The other thing is not going through a textbook or a book before solving problems. Especially textbooks give basic information that is necessary for understanding what the problem is asking. So it is very important to go through textbooks to understand the question and start solving problems. The next one is not checking with your classmates or professors about a particular topic if there is some confusion. Another pair of eyes helps you play the devil's advocate and helps you reinforce the learning that you have had. The last one is not getting enough sleep. Sleep helps you activate the diffuse mode, which helps you bring out novel solutions to problems that you have been struggling with. Power naps are also recommended during the day to kickstart the diffuse mode when you're having some struggle with a particular problem. These are some of the takeaways from the book, and I would definitely recommend this to people looking to especially hone their math and science skills. And this is not a book which teaches you different math and science skills, but it gives you a basic understanding of what is actually involved in learning science and math. The author concedes that math and science is hard and it is not easy for everyone to understand math and science. But through hard work and persistence and following certain patterns of researchers, it helps people to excel at math and science. She gives an example of father of neurology, a Spanish scientist named Kyle. He was an average mind and he was also delinquent in his adolescent years, but turned out to be a great scientific mind. So it comes through persistence. Leave a like if you like the video and subscribe to my channel for more book reviews. I've been Kaushik from the Thinking Monkey. I'll see you all next time. Until then, take care. Out.